After going to labofdata.com, users log in with two-factor authentication. Here I'm going to hide entering my auth app code. After logging in, users can navigate to their products page and select TrailBlazer after purchasing the product through Stripe. The default data set loaded in is 4 years of monthly average temperatures of 5 major U.S. cities. In the top right, we have our forecasting panel that contains over 45 forecasting algorithms users can use to forecast their data. With an Excel spreadsheet-like component below to upload, manage, and edit time series data. Users select rows of data they wish to forecast, and after confirming the forecast panel settings, can run their forecasts. Here we use RoadMap's Geneva forecasting engine to predict the next 12 months of monthly temperatures for these cities. Users are able to rerun forecasts with other models easily by selecting other forecasting methods in the forecast panel, such as ARIMA. After clicking Forecast, users can see their forecasts update in real time within the chart component and the spreadsheet component. The interactive chart allows users to select and zoom in on areas of the graph they wish to further inspect. Now let's test our machine learning model's capabilities by selecting the elastic net regression model and updating the forecast settings to use seasonal features and no transforming. Now we can rerun the forecast again to see how this machine learning model forecasts our average temperature data. Now that we have run machine learning, let's step it up and use RoadMap's custom pre-trained deep learning models, utilizing the NHITS deep learning model to rerun the same forecast. And again, we see the chart updating live. Oh wow, that was fast. Now let's step it up and use Nixla's new Time GPT AI time series model to predict the average temperatures. RoadMap partnered with Nixla to be an early adopter of this new type of time series forecasting. Users can reset the chart to its original view with controls in the top right corner. And for good measure, let's run Meta's Profit Time Series forecasting model, just to further show the range of the forecast models users can expect from RoadMap TrailBlazer. Now let's go back to forecasting with the Geneva engine, which is the fastest model that TrailBlazer offers. Now let's step things up and get some qualitative analysis of our forecasts. After running forecasts, TrailBlazer's AI analysis tools allows users to generate insights about the chart and allows users to add instructions/context for more custom AI analysis. We are going to leave the context blank to see the quality of insights the AI assistant can generate without instructions. Now, after a few seconds, the AI assistant will append its analysis to the notes section of the application. The AI assistant is able to identify all of the cities in the chart, along with the metrics being measured for each city. It accurately evaluates the historical data of each U.S. city, noting trends within the data, and analyzes each individual city's forecast while referencing data ranges from the chart, while also comparing cities to one another. This feature allows users to streamline their analysis process while providing accurate insights and evaluations of historical and projected data. The assistant also lists general takeaways and business implications of the data, making it a useful tool for demand planners and organizations looking to gain understanding of metrics and future trends as it pertains to their business operations. To maximize the analysis, users should provide context of their data so the assistant can provide the most accurate insights possible, but still with no context provided, the assistant returns impressive results. TrailBlazer also has a custom AI chatbot that can reference TrailBlazer documentation to return information about TrailBlazer and forecasting in general in case users have questions about forecasting models or performance metrics. Now that we ran our forecasts and have generated analysis, we can save our data and our notes to the app. After users save their forecast, they can leave the app, and when returning, their most recently saved forecast will auto-load into the application. I will demonstrate this by reloading the application and seeing my monthly temperature data automatically load in along with my recently saved notes, so I can pick up where I have left off. However, if I choose to work off a forecast I previously have saved, I can access it by navigating to my data, selecting my forecasts, and load in a previously saved forecast. I can resize the spreadsheet to view the data in full screen mode, along with a floating forecast panel to run forecasts from. The sample data here is of 8 years of monthly sales of a respiratory therapy. I can select any cell in the row of data that I wish to forecast, and then select my preferred forecasting method in the panel. Here we will use Neural Profit, a neural network-based PyTorch implementation of a user-friendly time series forecasting tool for practitioners. This is heavily inspired by Profit, which is the popular forecasting tool developed by Facebook/Meta, which returns 12 months of predicted sales for the therapy. Users can hide the forecasting panel for a better view of the data, and we can minimize the spreadsheet to view the results in the chart. The forecast looks accurate, so I am going to save it to my database, so I can retrieve my updated pharma sales forecast later. The chart component allows for further data inspection with full screen mode with the same ability to select areas of the chart to zoom in on. We can see that Neural Profit was able to successfully pick up historical seasonal demand and accurately forecast the sales peak in December and subsequent decline in January. Now let's reset the view and minimize the chart by pressing the Escape key. Now that we are back at the main screen, let's focus on how users can evaluate their forecast performance and run forecasts with conformal prediction. Let's edit the forecast settings to predict the next 3 years of monthly sales using Geneva. And now that we have our forecast, let's do a quick zoom in with the chart, then scroll below the spreadsheet component to view the forecast performance metrics, such as the forecast root mean square error, mean absolute deviation, and mean absolute percentage error. Now let's run the Time GPT forecast and compare metrics to see how each forecast performs. But with Time GPT, we can enable conformal prediction by selecting the detailed forecast option. After running the forecast, we can compare our last 2 forecasts in the forecast performance metrics log, comparing Time GPT's mean absolute percentage error of 3.08% to Geneva's 1.72% and Time GPT's root mean square error of 208 to Geneva's 97. To see the Time GPT's forecast with conformal prediction, click the View Forecast button under Detailed Forecasts. A chart of the conformal prediction intervals are displayed in an interactive chart with the ability to zoom in on portions of the chart and hover to view monthly interval values for the projected 3 years of data. This feature allows users to quantify and visualize uncertainty with their forecasts, view the data, and take notes about a specific forecast's conformal prediction intervals. We are now at the end of our TrailBlazer demonstration. I want to thank you for your time and hope that you found this demo informative and insightful.